there are so many laws of motion. We have equations of motion. So let's focus on equations of motion today. Equations of motion. Equations of motion. So under equations of motion, I will give you the 4 equations of motion. The first one, which is V equal to U plus AT. The second one, V square equal to U square plus 2AS. The third one, which is S is equal to UT plus half AT square. The fourth one, which is S is equal to U plus V over 2 times T. So we have 4 equations of motion. We have the first one, which is V equal to U plus AT. The second one, which is V square equal to U square plus 2AS. The third one, which is S equal to UT plus half AT square. The fourth one, which is S equal to U plus V over 2 times T. Now, these equations are very good, but we have to know the units. What is the value of all these, all these things? So now we're going to start with U. U is initial velocity. Initial velocity. V is final velocity. Final velocity. S is distance. You can call it distance or distance covered. We have T, which is that is going to be time. We have A, which is acceleration. Acceleration. I think with this we have been able to explain all the options, but there are some things you need to take note of. If a body is at rest, the body is at rest and is now, from that rest, it now started moving, it means that the initial velocity is 0. So a body at rest and moves later, it means that the initial velocity is 0. A body is at rest, but it moves later. It means that the initial velocity is what? 0. If a body moves and goes to rest, it means that final velocity is what? 0. So these are certain things that we have to understand. A body is at rest and moves. He later moved from that direction, moved to another place. It means that that initial velocity is 0. But a body moves and goes to rest. It means that final velocity is what? 0. So a body is at rest and later on it moved. It means that what? The initial velocity is 0. When a body now moves from here, it moves immediately, it did not start from rest. It means that the final velocity is 0. The final velocity is 0. So there are some velocity time graph, which will definitely with time we will understand the concept of velocity time graph. So if you see some velocity time graphs, some of them will just come like this. While you see some of them, they will start from rest, move like this, and come like this. So there are different velocity time graphs, VT graphs. So the one that moves from something like this now, it means this is not from rest, because this is usually the rest position. We are moving from here. So it therefore means that this one is not from rest. It means that the initial velocity is not 0. It could be 20, it could be 30, it could be 40, it could be 50. But this one, you see, it started from 0. So it therefore means that what? The initial velocity is what? 0. So there are different velocity time graphs, and we have to know how to really apply these graphs to what? To questions. These are very much important things to note. So like I said, the first formula states that V is equal to U plus AT. V equal to U plus AT. The second one says v square is equal to u square plus 2as. The third one says s is equal to ut plus half at square. The fourth one says s is equal to u plus v over 2 times t. If you can understand this, you are good to go. Then know that u stands for initial velocity, v stands for final velocity, s stands for distance, t stands for time, a stands for acceleration. If a body is at rest and moves, it means that the initial velocity is 0. If a body moves and goes to rest, it means that the final velocity is 0. Then you know there are some velocity time graphs where it just moves directly and goes down to rest. That is an example of this one I talked about, where I said the initial velocity is not 0. The initial velocity could be 20, 30, 40, 50. But for the other one where I said the initial velocity starts from 0, it moves from the beginning and goes constant and goes down. So yes, something I forgot to explain to you. This one now is accelerated, maintain a constant velocity, and decelerated. So you observe that this one accelerated from here. Acceleration is what? Moving up. The movement. See, acceleration going up. Then it what? Had a constant velocity and then decelerated. So there are different things, you know, acceleration, deceleration. Deceleration can also be called retardation. Retardation, that's when you apply brakes. When you apply brake, you observe that the car stops immediately. So brake what? Stops the car from moving. You understand? So there's acceleration, uniform retardation or uniform velocity, and there is deceleration. There are different concepts. But with this, I believe it has helped you to an extent to understand what we are doing.